Okay, and welcome to this next video where we look at using factor theorem to sketch cubic graphs. In the previous video we did look at factorising cubics, so we're just going to extend those ideas further in terms of sketching them. Okay, so in the previous video, as I said, once we get the factors, the graph can be sketched relatively easily. The most important thing was obviously getting those factors. So let's go through these questions and understand how to sketch them. So part A was cubic, and we're told the linear factor is x minus 1. So first of all, I'm going to try and find the other factors. Now I'm just going to use a much quicker method compared to linear division, which is an inspection method. Okay, and it basically comes from the fact that I know if I've got a quadratic linear factor, then to make a cubic I need a quadratic factor as well. Okay, so it will come basically from me looking at my linear factor and trying to make the quadratic factor by thinking about what the expanded question will look like. So how this works, I'll help you out with this first one, part A. I sort of think to myself, right, I want to get x cubed, so what would I expand x with to get x cubed? Well, it'll be x squared. And then I look at the number, so I've got minus 1 and I want to get minus 2, so what would I normally multiply minus 1 by to get minus 2? Well, it'll be plus 2. Okay, so I've got that part of the quadratic. The harder bit after that is trying to get everything in between. Okay, so let's just see what we've got at the moment. So at the moment, if I was to expand, I'll have my x cubed, I have 2x, I'll have minus x squared, but let's just focus on the x squared. So I've got minus 1x squared, I actually want 2x squared. So to get from that line, which I would have, you know, all these other things, I've got minus 1x squared. To get to 2x squared, I have to add 3x squared. Now to make a 3x squared, what I need to do is I'd have to have this x times by something in here to make a 3x squared. And that would be your 3x. Okay. Now obviously if I was to test this, let's just see if this works. So x times x squared, x cubed, x times 3x squared, x times 2x, 1 times minus x squared, well the 3x squared minus the 1x squared will give me the 2x squared, 1 times minus 3x, well we already had a 2x, so minus 3x will give me that, and then minus 1 times 2 will give me that as well. So this does check out. Now if I factorise this further, I'll get this, and that's the fully factorised cubic. Now to get the roots, obviously I'll make each of those brackets equal to 0. Okay, and then I'll sketch my cubic, and we've done this already in Pure 1, so it's just tying in factor theorem with this. So I know 1's here, and minus 1's there, and minus 2's there. Okay, now to obviously help me out in this question, I do need the y-intercept, and to get the y-intercept you just look at your cubic, it's the number at the end, so it's minus 2. Okay, now I'll just make sure that I get my shape correct, and it's a positive cubic, so it's going to have this general shape. Okay, so I've done part A, okay, using factor theorem and using prior knowledge from Pure 1 to sketch the cubic. So let's have a look at part B. I've got y equals x cubed minus x squared minus 8x plus 12, and they're giving me a linear factor of x plus 3. So again, I'm going to work with x plus 3, and I want x cubed, so I'm going to have x squared there. I've got 3 here, I want to make the plus 12 at the end, so I've got to have plus 4 here. Let's see what I've got at the moment with the x squared stuff. So at the moment I've got 3x squared, and I want to make minus 1x squared. So for me to do that, I need to subtract minus 4x squared. Okay, so to do that, I'm going to do x times something to give me minus 4x squared, which is minus 4x. Okay, now does this check out? This is all expand to get you what you want. Well, this gives me the x cubed, this gives me minus 4x squared, this gives me 4x, this gives me 3x squared, which gets me to that, which is what I want. This gives me minus 12x, plus the 4x gives me the minus 8x, which is what I want, and this gives me the plus 12, so this does work. I then factorize this, and I get this situation here. Now we've got to be a bit careful with this sketch for the reason that we've got a repeated root at 2. Okay, so it's going to intersect at x equals minus 3. Intersect at minus 3 and 2, and a y-intercept of 12. Okay, again it's a positive cubic, but when it gets to 2, it's not going to cut through it, it's going to bounce from that because of this repeated root. Again, we've looked at this in pure 1 already, and that's what's going to happen there. Just be aware of that. Part C, so we've got another cubic, the factor is x plus 4. This time, however, we've got a negative cubic, which is important when it comes to our shape, but also it does impact our algebra. So again, I want to get x cubed, but not only x cubed, I want minus x cubed, so I want minus x squared. What do I multiply 4 by to get minus 8? Well, that would be minus 2. Now think about my x squared term again. At the moment, my x squared term is minus 4x squared, and I want minus x squared. So to get from minus 4x squared to minus x squared, I need to add 3x squared. So I need to make a 3x squared. I do that by doing x times by 3x. Okay, like that. Now, once you've got to that stage, and like I said, that all checks out, you need to factorize further. It's going to be slightly trickier. Or you can obviously use a calculator to help you with this. So minus x and x, two numbers that make a multiply to give you the minus 2, but then should somehow add to get you the plus 3. So I think minus x times minus 2 is plus 2x plus 1. Yeah, I think that will work. So minus x squared plus 2x plus 1x. Yeah, that will work. So the x-intercepts are minus 4, 2, and 1. Okay, because if you make minus x plus 1 equal to 0, you get x equals to 1. I've got to be just a bit careful here because it's a negative cubic. And it's going to cut at minus 8 here, the y-axis, minus 4, 1, 2. Now a negative cubic goes in this general fashion, so it's going to come up through 2, go through at 1, cut at minus 4. It's going to have that general shape. Okay. And that's how we sketch cubics using factor theorem, and also using this method, which is slightly quick, which is a lot quicker than algebraic division. Obviously, the only tendency for error is in how you do your manipulation, really. But aside from that, once you get the hang of it, it is fairly straightforward. Okay, so that's how we sketch cubic functions using factor theorem.